Okay. Dear students, today we discuss a particular type of titration with our DT structures. So we have several types of titrations. One is volumetric, another one conductometric, then we have a potentiometric titrations. So every titration or every experiment has its own advantages and disadvantages. And first we can understand, and I try to understand how much you know about these conductometric titrations. Okay. So why we need a conductometric titration instead of an ordinary volumetric?
So as we know, in the normal ordinary volumetric titration, for the colorless solution, there is no endpoint will be founded.
For colorless solution, it's difficult to find the endpoint.
Yes.
Good.
In ordinary method, without indicator, we cannot find the endpoints.
We need color change to identify the endpoint.
For precipitation titration, conductometric titration is a better.
Because precipitation, we can't identify the exact color change or something.
In volumetric method, manual error occurs frequently, but in conductometric method, it can be represented through graphical. So the endpoint is represented by graphical. So manual error can be reduced.
So believe the instrument more than a human. Because we make more errors. Am I right? So this is the advantages. Yeah, we talk about the advantages. Now I want to know about what is the concept behind this conductometric titration.
The conductometric titration is directly proportional to the reciprocal of resistance.
The conductance depends on the mobility of the ions. Small ion has a high mobile than greater ions.
Smaller ions are highly mobile than
Larger ion.
larger ions. Any other points?
The increased neutralization takes place when the smaller hydrogen atom is replaced by the larger sodium ions.
From this reading, we can found the endpoint through graphical.
The endpoint is not directly from the, we can find it through the graph. So it will be more accurate, precise. Okay. Any other things? Okay, let we discuss about how this experiment, how this works. Okay.
This is a conductivity meter, and this is a platinum electrode or conductivity strip.
Do you have any cell constant for that?
Yes, sir. We have the cell constant. It is 1.0. So by dipping the electrode in the given solution, the mobility of the ion will be detected in the form of conductive titrations.
So the ions will be moving, and the electrode will measure the mobility
points.
of the. Based on that, the conductance is shown.
Yes, sir. By detecting these points, we can represent it in the graph.
Thank you.
We are going to see the reaction in conductometric titration. The reaction contains HCl and NOH, which combines and gives salt and water. During the combination, the smaller atoms of hydrogen atoms replaced by the larger sodium ions. We know that the HCl has a higher mobility, so the value will be high in graph. When the mobility of an HCl is high, so the value will be high. During the neutralization, the smaller hydrogen atoms will be replaced by the sodium ions, so the value will be decreased. After the complete neutralization, the value will be increased due to the reason of larger sodium ions.
From the readings we got from the experimental setup, we can determine the graph with the conductance and volume of NaOH. Volume of NaOH can be determined by the endpoint, which gives the amount of sodium hydroxide present in the titration.
Okay, first we discussed why we need this conductivity titrations instead of volumetric titration. We learned that there are several disadvantages in volumetric titration, and there are a lot of advantages in conductometric titration. That means it reduces the error. We do it by instrument, and we get the things by graph like that. And how we can do that has been explained by our friends. And to consolidate this, the conductometric titration can replace the volumetric titration with the advantages that, as mentioned by our friends. And also, the very important aspect is we measure the conductance of a solution. So conductance of a solution is a precise one through this instrument, And the endpoint is determined by graphene. Since the smaller ions continuously replaced by these larger ions, the value decreases. And after the endpoint, with the addition of a base sodium and hydrogen, the value increases. So intersection of these two produces a endpoint, which in terms the students has understood that it is more advantageous than ordinary titration methods. So we look into the potentiometric titration in the upcoming classes. Thank you.